Thank you so much, sir. Uh, Thank you so much, everybody, especially the guest speakers, the faculty members, and the students for joining us for this webinar in construction engineering and management at NUST. And I think we have been really, really fortunate and fortunate to have two international speakers. Well, one of them has obviously has studied at NUST, so and the other one is basically based in or like he is an international speaker, so both of them would be joining us. So I'll just give a brief description before we move ahead. uh, Generally we allot a time span of say 1 hour for the whole webinar, but well, obviously if there is a plus minus 10 minutes or say 15-20 minutes, so that is not at all an issue. So I hope the students join us today so they could benefit from this session. I would like to introduce the two speakers, Dr. AMirhossein Heravi and Dr. Fahim Ullah. Dr. AMirhossein is currently a senior lecturer and program director of construction management programs at the University of Southern Queensland, and he has completed his PhD in construction project management in 2014 at the Queensland University of Technology, Australia, and has been working in both industry and academia during the last 8 years. Amir has been teaching and developing various courses across the construction and project management discipline. His research interests are construction and project management, stakeholder management and involvement, risk analysis and management, quality management systems, building information modeling, and communication management. He has published several high-quality articles, won multiple research grants, and has been an active member of the Project Management Institute, that is PMI, and Australian Institute of Building. So this was something about Dr. AMirhossein Heravi, and let me introduce Dr. Fahimullah. Dr. Fahimullah is a lecturer in construction project management at the University of Southern Queensland. He holds a PhD degree from the School of Built Environment, University of New South Wales in Sydney, Australia, and has been a casual lecturer at the same institute for 4 years. He also taught various courses in project management at the University of Sydney as a lead lecturer. He has worked previously for three years as a lecturer at NUST, Pakistan, at the Department of Construction Engineering and Management. His research interests are construction management, project management, smart cities, digital technologies, and digital construction. So he has won multiple awards, research grants, and published more than 50 high-quality research articles related to construction and project management and smart cities. So once again, I would say that we are really, it's a privilege to have both of these speakers on board. And I would, in fact, uh, request the students to make the best of this session. If they have any questions, they should ask the speakers and interact as much as possible and benefit from this session. So, क्योंकि ये चीजें जो हैं basically these the things which they are going to talk about, this is directly coming from the developed countries, and I must say we once again that we are fortunate to get an opportunity to benefit from these ideas, these concepts, these practices and principles, what they are going to talk about. So without much further ado, I would request Dr. Fahimullah to start. Uh, Please, Dr. Fahim.
Thank you so much. Thank you so much, Dr. Huram, for the elaborate introduction. Thank you so much. It's always a pleasure and honor to join you guys and to give back to NUST. NUST has been instrumental in my career development, and I owe a lot of my success to NUST. So thank you so much again for this opportunity. Without wasting any time, I'll go into my presentation. The way we have divided it is that I'm going to discuss about digital construction and Industry 5.0 technologies, and then I'll hand it over to Amir to discuss about the research that we are conducting at USQ. Yeah, so we are not going to take more than 40 minutes combined, and we want to have more questions and more discussion, like a more interactive session. So I would like to keep it that way. Okay, so without wasting any time, let me share my screen. Um, I just need a confirmation. Can you guys see my screen?
Yes, I can see your screen. Any other the students or faculty members?
Yes, we can.
Thank you so much.
Okay, thank you so much. So let's start then. Um, let's start with the very basic definition of Industry 5.0. The topic of today's presentation is digital construction and a journey towards Industry 5.0. First of all, what is Industry 5.0 and what is all the hype about? So Industry 5.0 is all about the collaboration between machines and capitalizing on the human potential for getting the best out of it. Okay, so if you can see on my screen, um, it is about the interaction, and that is the two-way interaction between humans and machine. You leverage the machine's artificial intelligence and its processing through different sensors and actuators and displays, and you use the cognitive abilities of human being to make the most out of it. Okay, so it's machine coupled with human abilities. That's about Industry 5.0. Industry 5.0 aims at cost optimization. How? By reducing the time to conduct different activities. It aims for greener solution. That is, it aims to reduce waste and to minimize, day-to-day fluctuation between different activities. And it produces more personalization and gives opportunity to be creative about your solutions. Of course, we can have virtual education opportunities, especially that, now in this COVID times, in this era of online education, this is something that we can seriously think about, and definitely it will improve our communication both in class and on site. And to achieve that, we need the right technology. Right technologies, which one of them, which is very famous these days, is cobots. That is the collaborative robots. So different types of robots, that can imitate human behavior using AI. Then you have the very famous term digital twins. I'll explain this later on. And the Factory 5.0, which is synonymous to Industry 5.0 in terms of production. Okay. So what has changed from Industry 5.0? If you are aware of Industry 5.0, the key changes from that in terms of Industry 5.0 is the more focus on sustainability. So if you had been worried about sustainability and hearing the buzzword over and over, it's only going to get worse. You're going to hear more about it. So sustainability, of course, resilient industries. So more building more resilience. We have evolved from resilient cities. So it's not about cities anymore. It's about the planet. It's about the regions. It's more than a city now, and it's about industries. So you need to uplift your industries, make them more smart and sustainable, and then all of this should be human centric, and that is the focus should be on making the most out of human abilities. Okay, yeah. So while doing so, you can definitely reduce the waste, you can reduce the lead time, you can incorporate systems thinking, in education, communication, leadership, and of course, respect for people and value to the end user are at most important. Okay. So for realizing this transition to Industry 5.0, we need to adopt a human-centric approach. That is, we need to use more digital technologies, artificial intelligence, and similar approaches. We need to upskill and reskill the workers' digital skills. Similarly, we need to use more modern, resource efficient, and sustainable industries. In other words, we need to transition to a circular economy. That is, we need to go green. Okay, so all the buzz around green is going to increase more. And then globally competitive and world leading industries are required. And how do we do that? We do that by focusing on research and innovation. Okay, so in terms of the built environment, or more specifically in terms of construction, we need to focus on sustainability, we need to focus on resilience, and we need to focus more on the use of digital disruptive technologies. So when we talk about digital disruptive technologies, there are different disruptive technologies that are already there in the market. It's all about capitalizing on them and making the most out of them. For example, you may have heard of the term Big Nine technologies, such as big data, AI, robotics, drones, etc., etc. There are more than 20 disruptive technologies that you can make use of. Similarly, terms smart technologies, smart construction, smart and sustainable societies, etc., etc. All of them eventually contribute towards the smart and sustainable planet. Okay, so that's the end goal. We need to merge everything together in terms of the built environment and evolve from smart buildings. We need to think out of buildings. We need to think out of cities. We now need to think at the whole global level. Just think about COVID. COVID has not only disrupted a single country, a single building, a single city. It's all about the whole world now. It's about the planet. So we need to grow, and we need to think out of the box, and we need to think about the planet for this purpose. So taking this discussion towards digital construction is where we can actually leverage those disruptive technologies and move towards the industry 5.0. And what is digital construction? Digital construction is actually utilizing digital technologies throughout the construction project life cycle. So remember, it's not about the planning only. It's not about the execution only. It's from start to the finish to everything, including operation, the whole life cycle of the project. That is to construct and to manage the project more efficiently, timely, and of course with higher quality. So, think about the triple constraints of the project: the time, scope, and the quality, or the safety, or others, 10 project knowledge areas. All of them can be controlled if you leverage technologies in an effective way. So in terms of digital technologies in construction, we have BIM, that is building information modeling. We have AR, VR, that is augmented and virtual reality, and so many more technologies. I'm going to discuss a couple of them and how we have used it in our publications, and of course, how you guys can use them as well. So first of all, let's move towards BIM. Dr. Abdurrahman, he is an expert of BIM with us. So he can relate more to it, and of course he can later on continue this discussion with his students. So, talking about BIM, when we talk about BIM, people think BIM is only about buildings. I would differ here. Buildings, but other infrastructures as well. And when we talk about BIM, the concept has actually evolved from BIM. Now it's IIM, that is infrastructure information modeling. We also have tunnel information modeling, and we also have so many other modelings. So from BIM, it has actually evolved to IM, that is information modeling. It's up to you if you want to use it with BIM, with infrastructure, or with tunnel, or with other things. Okay. So basically, we need to understand here that it's not only about buildings, it's way more than that. Okay. So in terms of the dimensions, of course, when we think about BIM, sometimes people have this misunderstanding. They think that BIM is only Revit. BIM is only a tool. No, that's not it. It's definitely not it. There is a lot more to that. And it ranges from 2D to ND, from the 2 dimension to N dimension. And you can see over here, for example, the 3rd dimension is visualization. You can see it in 3D. Of course, here you can use Revit. Then you have 4D, which is time. You have 5D, which includes cost as well. You have 6D, which includes operations. Then you have 7D, which is about sustainability. 8D, which is about safety, and up to ND. Okay, so you can add as many dimensions as you want to BIM. Of course, these dimensions are there to be explored, so you guys can focus your research over there. BIM optimizes the work and company processes, and it enables better collaboration because different experts who are located in different locations can add at the same time to the model through clouds, so everyone can contribute, everyone can add to that. And at the end of the day, you have a more holistic and complete model. And definitely it can detect clashes, such as using Navis work. The next very important technology is about digital twin. And digital twin, it is a virtual model of a process, product, or service that replicates the real life working of any process. Okay, so what happens over here is that, for example, think about a real building. You start planning, you plan its digital twin as well. You start constructing, you can do that in the digital twin as well. You start finishing, of course, you can do that in the digital twin as well. And once you finish it, you can even go a step further and simulate it and operate it and see how it will feel like, how it will look like, how the operation will look like in real world. And of course, you don't need to really construct anything for this. You can go directly digital, do everything digital, simulate it, run it, check it, add people to it, go through it, have a walkthrough, everything, and then later on you can see if it is really worth it to construct it or not. And just evolve beyond that. It's not about construction only. Go to the operation stage, go to the facility management, go to the asset management, and all of those can be effectively managed using digital twins. So some applications of these digital twins, they exist in smart buildings, smart homes, smart cities. Um, yeah, and it can enhance the insight into the performance of infrastructure. And of course, you can produce digital and future-proof structures. Okay, so if I would to be summarize it in, if I'm to summarize it in 4 steps, it would be about building the twin, then the space utilization, and then visualization and simulation, and of course, sharing it with the people who are going to construct it. And there you go. That's it. Now you know the whole scenario and how it is going to happen, and then all you need is to start constructing it now. Okay. Another very important technologies is that of mixed realities, that is the augmented reality, virtual reality, mobile reality, or in other words, mixed reality. So it is a blend of physical and digital worlds where unlocking the natural and intuitive 3D human computer and environmental interactions is achieved. Um, in terms of the virtual and augmented reality, virtual reality means we are dealing in a virtual world. It is not there. We are imagining and we are going through it. Whereas augmented reality is actually adds to the real world. For example, you can have a look at a sign and then you can play with it using a computer. But the sign is there. But whatever you are doing, extra is not there. Just think about the game Pokemon Go. You were to collect different Pokemons, and those Pokemons were not really there, but in your phone you could see them. Okay, so that's a very good example of augmented reality. Other example is about mobile reality, and um, other example, for example, here you can see this crane is an augmented reality representation, and we simulated it on different sites to show how they work in different dimensions. Okay, the next one is about 3D scanning. 3D scanning is very, very important, especially when you are talking about old buildings or where you want to conserve, the heritage. Ancient buildings, you have no plans for them, but you want to create a digital model for them so that you can maintain them better, so that you can have a digital footprint of that. For that purpose, you can use 3D scanning. It digitally captures the shape of physical objects using a line of laser light. They create a point clouds based on detection of different points, and those points are actually the edges of the structures. Okay, a very important and recent terminology that is used these days is scan to BIM model. So you use a 3D scanner or a laser scanner to scan something, and then this is kind of how it looks like, and then you integrate it into BIM through Revit, of course, or other tools to create a pure digital twin, or to create a digital representation of your model. Okay, so this is something very important and very interesting, which you can definitely explore. Other important technologies is about the wearable technologies or the wearable techs. For example, you can have the smart goggles, a smart example, these can be used to detect falls for safe communication, location sensing, fatigue detection, even heat tracking and gas detection. Just think about mining only. Every year in Pakistan and even in Australia, something terrible happens in a mine and people lose their life. Just think about these smart sensing technologies and you have them. And if there is a minor gas leakage or a minor, reduction in oxygen level, you get an alert, instant alert. And you know now that this is a very dangerous area, you need to be careful. So how many lives can we save by using these technologies? Okay. Another very important area again is the construction IoT, that is the Internet of Things, which is based on the internet-based devices that can collect different kinds of data about the activity, performance, and conditions of building and other construction sites. For example, you can see over here that with smart cars, it can connect to a cloud-based data set, which can be shared with, for example, think about Google Maps. When you use Google Maps, you can see that it gives you information about traffic jams and everything. How does it do it? It does it based on this smart, GPS technologies. Similarly, you have so many UAVs, you have smart buildings or the building automation systems. All of them can be used for so much, so many purposes. So different sensors installed on different day-to-day things that we use can actually constitute this construction IoT, and which can help us manage our day-to-day things. Okay. Then you have the blockchains. Blockchain is a system of recording information in a way that makes it difficult or impossible to change, hack, or cheat. In other words, it secures your data, it secures your information, it makes it, let's say, hack prone or less likely to be hacked. A very good example in construction is about the use of blockchain is smart contracts, where you don't need to physically waste paper, you don't need to go to people to sign everything. Everything can be done digitally through secured keys. It is just like a secure vault, a secure bank. You get a key, you use your key, go to the document, sign it, and then lock it out, and that's it. Okay. So you can use it for renting, for funding, maybe contracting, fabricating, even transportation, and so many things. This can be used. And then we have the big data. Big data is when the data becomes so large and so huge that you cannot manage it using traditional technologies or traditional methods. For example, let's say the daily steps taken by all the workers on your site. Now, just think about it. You cannot count them. It is not possible to count them. So such type of things constitute big data. Okay. This is very important. The 10 V's of big data, which are listed over here. So there are different V's of big data that you can explore. Of course, big data analytics is something that is very much used in construction and smart cities these days. You can leverage the predictability. You can create so many beautiful and impressive graphs. And you can manage disasters through big data. And you can definitely manage waste, which is one of the serious problems, especially in Pakistan. So, all of these things can be managed through big data. And another important technology is that of drones. Drones, these days we call them eyes in the sky. Okay, you observe everything from the top, from the side, from every possible angle to detect any abnormality in the structure. Of course, it can be used in site monitoring, progress monitoring, asset management, infrastructure monitoring. You can create maps, you can manage risks, and it is definitely cost effective and superior marketing for project. Just think about a bridge. You cannot inspect a bridge properly using human resources, and that is, you will need lifts, you will need ladders. Sometimes it is not possible to go under a bridge in an ocean, or like a river. Maybe it's not possible to create one in ocean, but anyways, just to the side of a river, or something smaller, or a canal. So for that purpose, you can use drones. Drone will take you directly, let's say virtually, to the project. It shows you all the problems that are there, and then you have AI and machine learning. Just apply them. For example, for bridge crack detection, road crack detection, and you don't need to physically go there. You don't need to be there. It's all about, you know, using these technologies. So yeah, in terms of that was all about, you know, how you can use it. Now I'm going to give you some example how we have used different technologies in our works. For example, we have used these technologies, specifically machine learning for groundwater potential zone in Islamabad. Similarly, we have used it for urban heat island mitigation in a project in Karachi. We have used um, visualization and virtual reality to show different types of failures um, in columns and beams. Okay. Similarly, we used mobile augmented reality. Now, people may think, no, this thing is costly. It is not costly. Trust me. This gadget, this is a simple box that can be installed on any Samsung phone. You just install it on a Samsung phone, and there you go. You can detect, you can measure, you can analyze, you can visualize, you can see in mixed reality anything that you want that is visible to you. Okay. Similarly, you have the 360 cameras, the Samsung Fly, etc., etc. So these things are not costly. Some of them can be. For example, laser scanning is costly, but you don't need to. You don't need to do laser scanning right now. Maybe you can start with something that is attached to a mobile. For example, this is one of my colleagues. She collected data using a simple Samsung mobile phone with a very small gadget installed at its back. Okay. Similarly, we used open source data to detect floods in Swat, Pakistan. Okay, so you can see these are the flooded images and these are the flood detection that we have done using machine learning and AI. This is a bridge column in Australia, here in Victoria. We analyze it using AI. Similarly, um, this is another building. Now, important thing to note here is that, fine, these are cracks. These cracks are visible over here. We detected it using image processing, but some places, for example, this is not crack actually. This is a weaker point of concrete. We can detect this as well. You know, so, excuse me. So you can not only detect the cracks in the building, the damages in the building, but you can also detect the volatile points in any building or any structure. For example, as you can see over here, these red points are actually showing the damages, and the number at the end shows the severity. So the more closer to zero something is, that shows the more wider crack or the more, you know, damage to that point. Similarly, have a look at this example. Again, a huge crack detected and then analyzed. Okay, so not only can you see what's wrong in a structure in a building, but you also see potential weak points that can go wrong in near future. So while you are trying to fix this, let's say this area, you may as well do this as well. Okay, that is because sooner or later this is going to become like this. So this is something that you can use, you know, the artificial intelligence and those smart technologies, machine learning for. So that's all about the digital construction and Industry 5.0 from me. Now I'll hand it over to Amir, who is going to discuss about what we are doing at USQ, and then we'll take your questions. Thank you so much. Over to you, Amir.
Thank you very much, Fahim. Can everybody hear me?
Yes, we can, Amir. Thank you so much.
All right, thanks very much. Hello, everybody, and thank you for having us. It's a great pleasure to be here in this session, and I thank you, Dr. Koram, for facilitating this presentations and meeting, and also Fahim for introducing me to this group. So what I am actually going to do is to go to present to you a recent actually research project that we've conducted at the University of Southern Queensland. Fahim actually explained and went through some of the digital construction technologies, such as AI, augmented reality, VR, AR, BIM, you know, drone, etc. And in this particular project that I am going to present, we have actually employed some of those technologies, such as you know, structural health monitoring, UAV or drone, and integrating those with BIM. So I will start with sharing my screen. So can you see my screen?
Yes, we can.
All right, cool.
Yes, we can.
So the project that I'm going to present is a UAV beam integrated solution for structural health monitoring of Queensland bridges. So it was a grant project that we won last year, small grant though, but the main purpose of this project was to show the capacities and the potentials of building information modeling and other digital technologies and how they can actually bring benefits to construction projects. Um, so uh, it is very, very important that project maintenance is taken into account by project managers and maintenance managers. I have provided in this slide two examples of disasters in bridges. One is in Italy and the other one I think is in Philippines. And you can see that both these disasters has caused people deaths and so much actually economical loss, etc. And one of the major reasons of these disasters has been poor maintenance of these projects. So um, it brings the important points that how maintenance of these projects are actually important or actually becoming important day by day. So traditionally, structural health monitoring was done by visual inspections, right? However, as Fahim mentioned in his presentation, visual inspections require, assessment conducted by trained people, and which could be sometimes inefficient, and it is also subject to human interpretations, and in some cases it could be hazardous. So there is a great need that we move forward from a traditional methods of inspection to more digitalized methods of inspection. This project that we conducted last year had three main aims. And so the first aim was to basically inspect the project, which in this case was a bridge, using unmanned aerial vehicles or UAV in short, and the tool of that is drone, which is equipped with a camera and GPS to take project images and then convert them into a 3D model. As again, Fahim mentioned, sometimes in some projects you do not have the drawings. And because you do need the drawings to convert actually the people, sorry, not to convert the project into a software such as Revit or any other software that you're going to use to analyze the project, UAV or laser scanning and some other tools provide you with that facility to kind of laser scan and develop the 3D model of the project. Um, and then, but because GPS actually gets interrupted at some parts of the bridge, we also use DIC, which is digital image correlation, which allowed for enhanced structural health damage detection for the entire structure. So first of all, if you like, we collected the data and images of the bridge using UAV, and the second stage was using DIC, which was able to collect some of the images which were not actually which we were not able to collect from UAV. And the other factor is that UAV takes the static picture. So whatever the bridge is under any load, it will take the static pictures only. However, DIC takes the picture while the load is actually passing over the particular structure, and in this case, the bridge. And then one of the gaps that we used to have and still have in structural health monitoring and any kind of actually a construction project maintenance and even the construction side of it is the integration. So we do have data from different disciplines, we do have data from different departments. However, there has not been an integrated platform that can put everything together in an integrated manner, and then those information can be used by project managers and maintenance managers uh, to basically manage the project. For this purpose, we used building information modeling, and this technology provided us with an integrated digital methodology for more effective and monitoring during the whole project lifecycle. So as I just explained, this was actually the bridge. So in the first step, we collected. Well, there is a bit of a setup for the drone equipment. So you have to pinpoint some of the areas that you wanted to kind of scope around your project, and then the drone can be programmed to go and select the to go and collect the images. So with the images that we collected from the drone, we got a 3D model of the project. This was kind of an old bridge, so we didn't have the 3D drawings of the bridge from the council that we got the information from. So we had to do this to actually not only collect the images to identify the cracks or displacements or fractures of the bridge, but also to create the 3D visualization model. So this is the actual bridge, and this is us. So the next step was to, as I told you, the drone fly over the bridge to collect as much as information and pictures as it can to show the cracks and some information, but also we needed some dynamic images because we were going to measure what is the displacement when a load crossed the bridge. So for example, and what is the maximum point of it. So we had our DIC cameras here installed at a particular point. We actually measured this particular, so the second span of the bridge, and then I will show you in the next few slides how that work. So here we've got our DIC camera. So the DIC camera particularly captures the images and the movements of the bridge when the load is actually passing. And as you can see here, we've done a number of tests that and forward and backward with at different speeds. And then you can see here at which point of the bridge the maximum displacement happens. So this was basically stage 2. So as I said, we had 3 tests. One with a normal vehicle, the other one was with the truck, and the third one was with the truck carrying a vehicle, so that we can kind of compare the data together. And as I said, we in each test we kind of had different speeds to compare them together. Now, once we've got all the images from the drone, and we've got the images from the structural health monitoring from the DIC. So we know that, for example, at 50 kilometer per hour speed of this particular truck with this particular load, this is going to be the max displacement of this bridge at this span. Now, how that can help us? What do we do after here? And in this stage, BEAM is actually used to collect all that information together. And as I said, this was just a pilot study, so that we wanted to show how beneficial is using the building information modeling and how it can integrate all that information together. What I'm going to show you here is basically a quick overview of the outputs from the BEAM. So this is we used Unreal Engine to kind of visualize the project. Can everyone see the video which is playing?
Yes, we can. It's slow,
Right,
but we
cool.
we can see it. Yeah.
Okay. So now the basically the major component of BEAM here is that, as you can see, this is kind of in a schematic view of the truck and the bridge at different speeds. So if I click, for example, on 10 kilometers per hour, you'll see that the truck is passing. This is the span that we've measured. And there you go. Here is the maximum displacement point. So we know that DIC has done this. We know that some of the pictures has been collected from the UAV, but they are not into a single integrated platform that can be used for maintenance purposes, which BEAM provides us with this platform. So if I click on 30 kilometer, again, you see that the truck speed is changed and what is the maximum displacement and where it happens. And then again at 50K, it gives the same information. All right. Oops, sorry. I think I unshared my screen. I have to share it again. Okay. Um, So this was just a very, very small example of building information modeling and its capacities. So building information modeling, as mentioned before, is not a tool, it is a technology. And the more information you put into the building information modeling platform, whether and BIM is working with a number of software. It is very, very important to note that BIM works with Navisworks, it works with Revit, it can get data from UAV software, it can get data from structural health monitoring, from other software, and then can put everything together to show in a visualized format. In this particular project that I shared with you, we only had a very small amount of information, which was just the displacement of the bridge, and this project was already being built. So the major benefit of BIM happens when the project has not already been built, actually or physically. You can still visualize the project, and as you can see here in these examples, you can identify the clashes. So you can walk through the bridge, you can walk through the building, you can walk through the infrastructure, as Fahim mentioned, because building information modeling is used for many projects, and then you can see the project virtually. And importantly, as I said, the project has not been built yet. So you are able to identify the clashes, you're able to identify, where you need some improvement, and then from this information, you are able to identify, okay, this team needs to work first. These are the amendment needs to be done in the drawings, needs to happen in the drawing. These are, sorry, um, or what else you need to do. And then you can imagine that how cost saving eventually it's going to be. I think everyone knows that the rule of 1, 10, 100 means that any clash or any defect happens or identified in the planning stage, where the main application of BIM is going to cost you $1. Same issue in the design phase is going to cost you $10, and the same issue in the construction phase is going to cost you $100. So you're going to actually minimize the cost of rework, if you like, later on in the construction phase of your projects. These are the outcomes of Navisworks. So the more, as I said, the more information you have, the more capability BIM gives you. Even in this example that I showed you, for example, if you give the BIM team more information, the BIM can provide you with the opportunity to, for example, click on this particular element of the bridge or any kind of structure, and it gives you all the information about it, the character of it, the material, when it's going to be need to be fixed or maintained, and any cracks or any other information. And again, when the project has not already been built, it gives you a lot of information that can help you, both the clients and the project manager, to visualize the project before it goes to the construction, design and construction stage. I am not going to speak more on this because I think Fahim has covered many of these. Um, as mentioned by Fahim, construction industry is moving towards digitalization. We have been actually at a slower pace in the last, I would say, 10 to 15 years, but now it is picking up. So we are moving towards VR and AR, green buildings. We are moving towards sustainability, 3D printing. I would assume that in the next 5 to 10 years, at the moment we have some construction, maybe simple story or single story buildings or up to 5-story buildings in some parts of China. I've heard that there has been some 10-story buildings that have been used, that has been constructed by 3D printing. Very quick, very accurate, and very cheap, although the cost of installation might be a little bit high. But if you consider the long-term cost with the labor and the material, it's going to bring down the whole life cycle cost down to very much, actually. It's IoT, big data, AI, and smart management, drones, and smart material are the future of the construction industry. Thank you very much for your attention. And
Thank you so much, Dr. Amir. It is indeed a pleasure to have you here. And the presentation basically and the information has been really, really useful. I'm pretty much confident that it has been useful for the students and the other faculty members as well. And thank you, Dr. Fahim, for your presentation as well. It was really informative and really insightful. Now I would request the faculty members and the students, in particular, to ask questions from Dr. AMirhossein, Heravi, and Dr. Fahim Ullah, if they have regarding the presentations and the. So please go ahead. Anybody?
Sir, I have a question.
Ji, please go ahead. Sir, respond, please.
Okay, thank you very much for a very nice presentation. We are actually working on the same topics on digital twin, and we are trying to use sensor networks for near miss detection and a lot of stuff on safety and robotics as well. So there is in some of our discussions with our postgraduate people, they are saying that the word digitization and digitalization, they are two different things. So are these two different things or is it the same thing?
Dr. Amir, you want to answer it or should I go for it?
I think that digitization is part of the digitalization, because when you digitalize every project, you're actually looking at it from a bigger picture. So for example, you're using some artificial intelligence. We call that digitalization. And then within that digitalization, there would be some sort of micro systems that are actually getting implemented. That would call it digitization. That is my understanding of it.
Yeah, I would just add to that. When we talk about digitization, digitization is converting data into digits. That is generally how computer works in binary terms, ones and zeros. For example, if you remember one of the pictures that I showed you about that graph, that crack, which was from 0 to 10, about the intensity of the crack. So that is where we digitize the crack. That is using the computer vision and machine learning. So when you convert images, when you convert, let's say, any aspect of a specific thing that you are investigating, that is called digitization. And then the sum of those digitization, along with different tools and techniques for visualization, actually formulate what we call the digitalization. So digitalization is more about disruption, and digitization is more about usage of computer technologies. Yes, that's how we differentiate it. So as Amir said, digitization is part of digitalization. Thank you, Dr. Osman. Thank you.
Thank you very much.
Yeah.
So if there's no, like, one more thing I want to ask, like, what is the focus of research? Like, what do you think? Is it more towards artificial intelligence, or are we moving more towards robotics? So
it depends. It depends on the available resources and the facilities. For example, with AI, you don't need a lot of resources. You can start with simpler images as well. You can apply AI on anything. But for robotics, you need high-tech gadgets and maybe more investment in terms of sensors and in terms of more mechanical expertise along with the civil one. But for artificial intelligence, it's more easier. Specifically in terms of MATLAB simulations and in terms of machine learning tools and computer visions, you can use AI for that purposes, and it's kind of less costly compared to robotics. For robotics, of course, like Amir said, for 3D printing, you need high-tech gadgets, and those are very, very expensive. For example, a normal 3D printer costs like more than $100,000. So it's very expensive. So it depends on where you want to start. If you want to work in a high-tech environment, of course you should go for robotics, and then add AI to robotics. For example, in cobots, which is the collaborative robots, you use AI along with robotics. Okay, but if you are short on resources, I know I come from NUST, I come from Pakistan, so I know we are a little bit short on resources over there. So for there right now, the good idea would be to start with AI and machine learning, and then maybe you can collaborate with a developed country where they have more resources to introduce robotics as well. So that's kind of where you can capitalize on others' resources and make the most out of it. Yeah,
We
that
would
would be
love
my suggestion.
we would love to collaborate with you.
Of course, why not? That's one purpose of this meeting. Why not? We wanted to show you what we are working on, and of course, we would love to hear more from you. I'm taking the leverage in the presence of Dr. Amir to say that yes, we are more than happy to collaborate. Why not?
Absolutely.
Thank you. Thank you.
And just to add to that, apart from building information modeling and AI and VI and these kind of digital technologies in construction, we also have some focus on sustainability and waste management. That is a very, very hot topic in the construction in Australia, and I know in other countries. I'm originally from Iran, and we are neighbors actually with Pakistan. I know that in that region, waste management has always been and is still going to be a very hot topic of research. So our main focus is on in sustainability, digital uh, aspects of construction, could be BIM, 3D printing, etc. But also we do have some researchers and PhD students who are still working in the traditional construction project management, such as, for example, procurement management. Recently, I and Fahim has got a PhD student from from Nigeria who is working on procurement, but he is actually going to develop a framework to kind of advance procurement. So we are actually getting some movement from the traditional type of project management knowledge areas to more advanced. So it's kind of the areas that we would like to collaborate.
Yeah. Thank you.
All right. Any questions from the students? Okay, Dr. Abdurrahman, please go ahead.
So, thank you very much for the opportunity to learn from your good, wise presentation. Thank you, Dr. Amir and Dr. Fahim as well. I myself, being the teacher as well as the student of building information modeling, I kind of foresee the future of industry in a very different manner. Like, since we are going and watching the integration of the digitization, or what we call the digitalization, or all the informatic aspects into the construction industry. First question is, don't you think the gap of what we predict about the developing construction economies, that from those of the developed construction economies will be more huge? And secondly, does it not warrant a total paradigm shift of the construction curriculum for the undergraduate degrees, be it for the civil engineering as well as for the architects? Because we in Pakistan, I was in Germany, I've seen there, and you might as well have seen in Australia, that or in Iran as well, that we do not have the core informatics part integrated into the curriculum of the undergraduate degrees, which might be a need of the hour.
100%. Yeah.
That is a very, very good point. I don't know who is actually speaking, but
It was Dr. Abdurrahman.
Abdurrahman, yeah. That is actually a very good point. I think, and that is something that we are actually at an Australian university is focusing that we need to build up that fundamentals for students. However, having said that, I think the core aspects of the programs whether it's going to be civil engineering or construction management or construction project management, would be based on the fundamental knowledge. So students needs to learn and understand the fundamentals. However, as you said, we are also introducing some new elements and new components to our programs to kind of shift it towards the digitalization in construction. That is not going to happen overnight. That takes, that takes a few years so that it can then be kind of a universal. So like in any bachelor of civil engineering around the world, students will learn statics, they will learn dynamics, etc., etc. But it will be some sort of digitalization in construction as a curriculum topic, I would say, in the next 3 to 5 years in some countries, in most of the countries.
Yeah, so I definitely agree to that. Just to add to that, we are seeing a very serious shift towards the digital education in Australia. For example, it's kind of, not written, but kind of implied that every undergraduate degree should have a component of digital construction now. For example, we are introducing a course on digital construction at USQ undergraduate level from the next semester. Similarly, it is compulsory for all of our master's students to take a digital construction course in our master's program. That is the compulsory course. They have to take it. So, it is there. I know at least around 8 Australian universities who have made it compulsory for all their master's level students at least to take digital construction course. But of course, it takes time, to trickle down to it's not right. That is, that is being adopted, that is being talked about. So what I can say is that it will take some time for developing countries to move toward this. Of course, if I want to, name a number, it will take around, let's say, 5 to 10 years to be started to be taken seriously in developing countries, and then it warrants huge investments. For example, even just to give a very basic idea to the students about, let's say, virtual reality, you need to have at least the Samsung VR kit. So universities need to invest in that, and in Pakistan particularly, HEC needs to realize this and to have at least a digital lab in all the universities. Now I know it's hard, I know it sounds impossible, but sooner or later it has to be done because there are so many motivation factors. For example, be it the Washington Accord, be it the international accreditation, all of them will eventually force them to adopt it. So what you guys, or what, let's say, people over there need to do right now is to start thinking about it. If you start thinking about it now, in 2 to 3 years you will be in a position where you can actually adopt it. But if you delay the thinking, it will just add on those 2 to 3 years about it, and it will actually be more delayed. For example, when I was doing my research back in 2015, I realized that in terms of the simple understanding of PPPs, there is a 7 years gap between industry and academia. So what academia is doing right now, industry talks about it around 7 years after that. So in Australia, it's different. It's the other way around. Industry actually introduces things. Our industry actually collaborates with the academia to develop something for them. They give them grants. So we need to have a shift in terms of both the the thinking of the industry as well as the academic side. So it is hard. I'm not saying that it can be done very easily, but we need to start thinking about it, and we need to produce globally competitive graduates. For example, when we think about Pakistani graduates, or let's say any developing countries graduates, the problem is that we people from developing countries are very, very talented. The only problem is that we are not exposed to such environment. We are not exposed to those high-tech environments and high-tech technologies, and that is where we kind of feel shy. We kind of feel low on self-esteem, when we are competing in a high-tech world. So the least we can do is to start motivating students to think out of the box, to think about them, and the best way to do it is to start developing conceptual frameworks for various adoptions. For example, it will not cost you anything to explore the adoption capabilities of Pakistani construction industry for VR or for for big data. It is not going to cost you a lot. Definitely you don't need text for that because you are exploring the capabilities. Once you have the capabilities explored, you can develop a holistic document. You can share it with the industry and give them guidelines. Look, this is how you can do it, and this is how you can help us enhance the abilities of our graduates. So that is kind of my suggestion, which we can definitely adopt over there. Thank you, sir.
Thank you
Thank you
very
so much. Dr. Jamal, please go ahead.
Thank you very much, Amir and Fahim. Very, very insightful presentation. I had to steal the limelight here, but in Pakistan, there's been some work towards digital education happening. I'm part of a couple of committees constituted by Pakistan Engineering Council, where they are working a lot towards improving the curriculum. But I understand it is still a lot far away, and that's what my question is. Because I mean, it's okay. We and one of the by the way, one of the participants here in this presentation was Fida Siddiqui. He's currently a PhD student in Swinburne. I'm co-supervising his PhD. He's also working on development of digital skills for engineering students. So again, developing the curriculum interventions. But my question is, uh, yes, we have a lot of challenge on the supply side of the things, prepare graduates with those digital skills and all. But what do you guys reckon about the demand side of it? And when we talk about demand side, Dr. Nasir has been dealing with industry a lot to train them in BIM and other digital technologies. But my question is, don't you think that when these technologies operate in isolation, one project here, another project there, for research purpose, yes, they look very good, produce very, very promising results and get published. But when it comes to actually implementing those in industry, the entire ecosystem around such technologies, be it contractual, be it risk, be it skills availability, etc., etc., where do you think that entire ecosystem is, be it developing world or the developed world, and what do we as academics need to do to make sure that ecosystem continues to develop?
Dr. Amir, do you want to answer, or should I go
I
for
think
it?
that's a very, very good question, Jamal. I think uh, I had an incident just about 2 years ago. Exactly, a problem was identified with one of our industry partners. That industry partner is a software company that develops application particularly for the construction industry. And one of the issues that they had was that, okay, in a multi-billion-dollar project, for example, in a 30-kilometer tunnel, we have a number of people that working in different sections of this project, and we have a lot of paperwork every day to control the traffic, to control the incoming material, machineries, etc. And everything is on the paper. By the time it gets to the project manager, it's 1 week old already. So that company came up with a problem that we have developed an application that it's like a live application that you can put information at every time that you deal with that incident. And at the same time, your project manager can see that how many trucks, for example, today get into the construction site. And the issue was that why people do not adapt it. I would call three main things here, Jamal. One is the demand. The demand is there and will be increasing in the next few years. For example, in the UK construction industry, using building information modeling has become mandatory in governmental projects. In Australia, it will become mandatory from 2023 for projects over $50 million. And it will go away, it will go ahead like that. So the demand will be there and will be coming there. But the more important, and the supply, as Fahim mentioned, will come from academia, because here academia and industry work very closely together. So the problem sometimes is identified by the industry and resolved by academia, or the other way around. The problem here, that as far as I can see, is the adaptation, is this transition. How long does it going to take? Because always there is a kind of a resistance to change. If you're talking about laborers, we're talking about people that have no knowledge of the advanced technologies. A person that has been using pen and paper for 30 years to just, note the number of trucks that come to the site. It is very difficult to convince them that, okay, you have to put this aside and then use your mobile or any other applications. So but I think in the next 5 years, the industry is moving towards that direction. So we will have that adaptation coming into place in the next 3 to 5 years.
All right.
Thank you.
Thank you so much. I've
And
got
I
a
think there
question
was,
as well,
yep.
so I raised my
Yeah,
hand.
yeah, sorry. So just to add to what Dr. Amir said,
Yeah.
if the demand is not there, then the demand should be created. It's as simple as that. You need to target your consumers, your end consumers, and you need to, first of all, you need to educate them. And where do we start that education? Right in our universities, because our graduates are going to hit the market maybe next year or maybe a year afterwards, and then these are going to be the people who are actually going to demand those technologies. For example, we had a trial at UNSW for one of the new developed software, and the developer actually offered that software for free for all the students, and he trained our students for free. Now, the developer was very smart. What did he achieve from that? He achieved a huge batch of students who were aware of his software, and once those guys hit the market, they demanded that software. So his sales increased. So once you have students who are ready, who have those skills, they will start demanding those technologies. They will start demanding, and this is how change happened. Of course, as Dr. Amir said, it is not going to happen overnight, but at least you need to plant the seed right now in those graduates, in those students. And then we need to be a little bit active as academics. We need to have marketing strategies, and we need to make them realize that this is the future, this is where you are going to survive. For example, go back around 5 years ago, and there was no contactless parking in Australia, and now it's a main feature of every parking plaza. You don't need to put that paper in or out of those things. It's automatic. They scan it and you can tap, or you can even pay online. So these things, for them, you need to create demand. Maybe you need to have a trial run of something. You need to arrange seminars. You need to educate the people who are there in the industry and make them realize. Those people, for example, contractors, mostly in Pakistan, they don't understand technology, but they understand money, and they understand it better than us because it's their bread and butter. If you convince them that adopting, let's say, the smart contract will save you 100,000 rupees, let's say, in 6 months, they will definitely adopt it. But this is all about us convincing them. This is all about us showing it to them how it can be done. Maybe we need to convince some developers to develop something, and then so it has to be more academic led strategy, but at the same time making them realize that there is a scarcity of this thing that can be utilized to make more money, or to make whatever they are interested in. Or in addition to that, of course, the government and the HEC or the PEC, or whoever is the governing body, maybe Ministry of Science in Pakistan is a very good candidate for this. If you can convince them, they can at least start adopting it in the government organizations, and then there you go. Once a technology hits the market, it's inevitable to be adopted. People will adopt it eventually, but it's all about hitting that first nail and hitting it, where it matters. So we need to have those consumer focused strategies where we are more closer to our audience. We need to listen to their feedback. We need to understand their concern. For example, why would someone not want to have a technology? Is it money? Is it their capabilities? Is it their infrastructure? Or is it just the fear of the unknown, that they just don't want to be exposed to something that they are not expert in? So we need to develop those strategies. And as I said, once you start exploring the adoption capabilities, you tend to realize those barriers, those challenges, and then you develop strategies for mitigating those challenges, and eventually there you go. you have a pathway for adoption. So, this is how I think we can go for it. Yeah, thank you.
Right. Thank you so much, Fahim. I've got two questions basically. One is a pretty basic question, and it is related to Industry 5. So my question would be that how would you explain the journey towards, like, what is basically in layman terms Industry 5? What do you mean by Industry 5? And secondly, Dr. Amir mentioned about sustainability and circular economy and its importance. So yes, I personally see a lot of importance, particularly being laid in the developing countries nowadays, in sustainability, and now increasingly there is a shift towards circular economy as well. Although circular economy is much more uh, like prevalent in the developed countries, the idea has been there in the developed countries, but it is creeping in. It is slowly coming in to the developing countries as well. So, what do you think that the ideas like sustainability and the digital construction has its implementation in terms of sustainability and circular economy, keeping in view the developing countries in context? So these would be the two questions I have.
You want to go ahead, Fahim?
Yeah, sure. So first of all, for the Industry 5.0, if you want me to explain it in a layman terms, just let me tell you the story, how this industry thing started. So, when we talk about Industry 4.0, it is fourth industrial revolution, which actually started with the introduction of different types of digital tools. We used to manage everything using traditional methods, and then these digital things started, and we started moving towards digitalization and more towards sustainability. So actually the sustainability, the buzzword that sustainability is, it started around Industry 4.0. And we had all those people, coming from different angles. This is sustainability, that is sustainability, blah, 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 blah. But eventually, now that we know what is sustainability and what are digital technologies that we have with us, Industry 5.0 tell us how to use it more effectively. So the technologies now. Industry 5.0 tell you how to merge those technologies and how to use to make the most effective use of the human abilities to make the most out of those technologies. Okay, so that is the fifth industrial revolution. That is, the focus is shifting from technology towards assisting human being with those technologies. Okay, so more towards increase in productivity, more towards increase in interactive abilities of the human beings with those technologies. That is your Industry 5.0. And what was the next question, sorry?
It was related to sustainability and circular economy. It's like its implementation, particularly in the developing countries, like the digital construction and its relevance to sustainability and circular economy in the context of developing countries.
So I will give you examples for that. For example, one of the best example that we have right now is waste minimization. You can minimize waste. You can go towards more reuse or recyclability of those materials to move towards the circular economy. Okay, so Dr. Amir, do you want to add something to this one?
Yeah, no, go ahead. I'll have a couple of points after you.
Yeah, sure. So, so that is where developing countries can chip in. I know when we talk about developing countries, I don't expect developing countries to be, let's say, using state-of-the-art supercomputers, because it is expensive, because those gadgets such as 3D scanners are really, really expensive. Even some universities in Australia, they are very kind of tentative about buying them because they are very, very expensive. So I don't expect developing countries to use, let's say, the 3D scanner for now or 3D printer for now, but at least we can start with other digital techs, let's say, like the AR or maybe the VR or even drones. Drones are everywhere now. People fly drones for fun. Now, how about we take some pictures from drones and then use AI with that? So all those easily are less costly and more effective methodologies that we have. In other words, we can be selective about what we are going to use from those digital technologies in developing countries. And once you have something to show to, let's say, a funder or a developed countries, you can use their labs, you can collaborate with them to build towards the high cost aspect of that. Okay, so my suggestion personally would be, in terms of sustainability, of course, you need to be sustainable in terms of cost as well. So we can start up with those low cost technologies, and then we can move towards the higher ones. And there is a strong need to motivate the government or maybe the ministries to invest in those technologies. For example, if you create 3D plans, or just the virtual model of, let's say, a heritage site in Pakistan, and you can convince one of the ministry for heritage and culture to show it to them, and they invest in that, and you can buy, let's say, a 3D scanner for that. So this is how you can move ahead with that aspect. And a very important aspect that is very much neglected in almost all developing countries is that of the social aspect of sustainability. When we are designing projects, we rarely think about the culture and about the people. We only think about the cost. And unfortunately, most of the discussion in sustainability revolves around the cost. So maybe it's the right time to start thinking about the social aspects of those digitalization, or maybe where other people are moving towards those high tech and gadgets. Maybe in developing countries we can focus more on the social side, more environmental aspect, and then you develop those sides, take the high tech side from the developed countries, and there you go, there is your sustainability. Okay, so as I said, we should not be leaving anyone behind. It's like COVID. If you close your borders just like Australia did, you cannot do that for the rest of the human life. You have to be open to the world, and once you are open to the world, this COVID, this disease or whatever it is going to hit you. So are we prepared for that? We need to work with the developing countries. We need to work with everyone, and that's how we can work on these digitalizations as well. We need to uplift everyone to be in a position to have a global adoption. And this is where we can help each other. Yeah, over to you, Dr. Amir.
Right.
Yeah, I just wanted to mention a couple of points. I think what you say, Koram, if I'm spelling your name correctly, is actually very important, because one of the issues that we have in the construction and project management area is that the outcome of our project is not immediately tangible. For example, if you're working in the manufacturing or production industry, the outcome of your project, for example, is a mobile phone that everyone can see and everyone can touch and everyone can see the benefits of it. In the construction and project management area as a whole, when you say to a client or a contractor that if you implement this system, whatever it is, whether it's a digital construction or a sustainable project or a value engineering, strategy, it is going to save you 20%, money at the end of the day. Because they don't see it in the beginning, they will be a little bit reluctant to that change. But I think a very important point that Fahim mentioned, I also had a conversation with one of the universities in Iran a couple of months ago, and I said the first point to start is to reach out the people who has the money and are willing to chip in some money to do some research and actual project, such as government organizations, big universities, etc. So once you've got a trial, once you've got a pilot project that has gone successful, then everyone will see that and everyone will see the benefit of that. Apparently, you will not have everyone to adapt that technology, but in the long shot, people will start to realize, if I want to survive in this competitive market, I have to adapt this technology. And that is not only, you know, specific to developing countries. Even in Australia or any other developed countries, nowadays very small contractor or construction firms approaches us for building information modeling. Because they have seen that around for a number of years. They have seen that it's been adapted with a number of big projects or big companies. Now they want to implement it. I think that mechanism will be implemented in our developing countries. One, it is out there, as Fahim said, once it hits the market, whether by, you know, government organizations, municipalities, or other large organizations, and a number of projects runs those sort of digital construction sustainability, and people start to realize and see the benefits of it. Then, because we live in a global village, everyone knows that. Some countries actually moving at the faster pace, some countries moving on you know, slower pace. But if you ask me 10 years ago that everyone needs to have credit card to pay the money. In a country like Iran, I would say everyone will laugh at you. Oh, maybe 15 years ago, how can we replace cash with our credit cards? But now when you go to Pakistan or when you go to Iran, no one carries cash. Everyone has got a credit card because people have to adapt the new technologies. It will take time and it needs some strategies, but we will get there eventually.
Yeah, and just a final touch to that. Your question was about the sustainability and circular economy as well. So in terms of, you know, when we talk about the sustainability or the sustainable circular economy, we are literally talking about recycling, reusing, and, you know, remanufacturing things. So whatever you are going to develop should be reusable, of course, recyclable, and then remanufacturable. So if you follow this model, it actually creates 4 times more jobs for people. It saves you money at the same time, and it helps you generate money, more economy. For example, think about generating energy from waste material. Waste material is going to, you know, go to waste. How about you generate energy from that and then recycle it to reuse it? You know, so that is where your sustainability and circular economy can be merged. That is the point. Yeah. Thank you.
Thank you so much. Thank you so much, Dr. Amir and Dr. Fahim. I think if there is a single question we can take before we close the session.
I would just sorry to jump in. You know, I was a student as well, and most of our students are actually kind of shy to ask questions in English. So if anyone can ask a question in Urdu, it's fine. I can translate for Dr. Amir. So अगर
Right.
किसी का सवाल है तो वो स्टूडेंट्स उर्दू में भी पूछ सकते हैं, कोई अंग्रेजी जरूरी नहीं है, कोई इतनी अच्छी हमारी भी नहीं है. तो any questions from the students, please?
So any questions from the students? As Dr. Fahim put it, basically, it is not necessary that you have to speak in English. You can talk in Urdu, basically, national language.
So I can speak that.
I think they're gone into hibernation, or I don't know.
Probably no
Anyway,
question.
I think we've already asked quite a lot of questions, taken a lot of your time as well. On this note, I think we'll close the session. But before we close the session, I would once again take the opportunity to thank Dr. AMirhossein and Dr. Fahim for sparing their time. It is not an easy task, trust me. Going through a webinar or giving a presentation and going through all the details, it kinds you make you numb at the end of the session, and especially answering the questions. So I'm really grateful on behalf of the faculty members, on behalf of the students of NUST, and we look forward to collaboration in future as well. So thank you so much, and
Thank you very much for having us, and thank you again. Thanks, Fahim, for introducing me to this fantastic group of people. We would be more than happy to collaborate with you for any potential opportunities.
thank you so much. That is really nice of you all.
Thank you very much.
Thank you. Okay. Take care, and Allah Hafiz from our side.
Thank you so much. Thank
Yeah.
you. Thank you.
Bye-bye.